Today we discuss about qualitative analysis. Inorganic qualitative analysis. Analytical chemistry could be divided into three main parts: qualitative, quantitative, and applied. Quantitative analysis deals with detection and identification of different substances singly or in mixture. This part deals with the qualitative analysis of anions, which could be defined as the negatively charged fragments of salt or compound. Alternatively, anions refer to acid radical. An example is NaCl, Na plus plus Cl minus. Na plus means cation, it is basic radical. Cl is anion, it is a acidic radical. Anions are divided into 6 groups. First, carbonates and bicarbonate group. Second, sulfur containing anion. Third, halides. Fourth, cyanogen anion. Fifth, arsenic and phosphorus containing anion. Sixth, nitrogen containing anion. Carbonates and bicarbonate group. CO3 2 minus, HCO3 minus. General character. First, parent acid. Carbonic acid H2CO3 is a very weak volatile acid, stronger than HCl and boric acid. Heating of solution of H2CO3 and CO2 will evolve H2CO3 equilibrium CO2 plus H2O. Bicarbonates are considered to be the first step of ionization of carbonic acid, while in the second step carbonates are formed. H2CO3 equilibrium gives H plus plus HCO3 minus. It gives H plus plus CO3 minus 2. CO3 2 minus. Second, solubility. All carbonated with the exception of those of the alkali metals Na plus plus and K plus and of ammonium are insoluble in water. All bicarbonates are soluble in water. Second, general reaction. Dry reaction. Action of dilute HCl. Decomposition with effervescence due to the evolution of CO2 gas for both CO3 minus minus and HCO3 minus. CO3 minus minus plus 2H plus CO2 evolve plus H2O. NaHCO3 plus H plus gives CO2 evolve plus H2O plus Na plus. This is a type of displacement reaction in which stronger acid liberates the very weak carbonic acid which spontaneously decomposes to CO2 and H2O. Test for CO2. The solid substance is placed in a test tube, dilute HCl is added which immediately displaces the gas which is evolved and passed into the lime water or battery water contained in another test tube. The production of a turbidity indicates the presence of carbonates or bicarbonates. Some examples are: then, with prolonged passage of CO2, the turbidity formed due to the insoluble carbonates slowly disappears as a result of the formation of a soluble bicarbonate. CaCO3 plus CO2 plus H2O boiling HCO3 2. Wet reaction. In order to carry out the wet reaction, a solution of the substance in water must be done. Bicarbonates are mostly decomposed on heating with the liberation of CO2 to HCO3 minus gives CO3 minus minus plus H2O plus CO2. A reaction with AgNO3, white precipitate of silver carbonate is immediately formed. CO3 minus minus plus 2Ag plus Ag2CO3. The precipitate is soluble in mineral acid nitric acid, and in ammonia. Then a precipitate becomes yellow or brown if the mixture is boiled. Reaction with BaCl2, CaCl2 and MgSO4. White precipitate of BaCO3, CaCO3 and MgCO3 will be obtained upon the addition of these reagents to sample of carbonate solution. BaCl2 plus NaCO3 gives BaCO3 plus NaCl, Ca++ plus CO3 minus CaCO3, Mg++ plus CO3 minus MgCO3. The precipitate is soluble in mineral acid. For HCO3 minus, no PPT on cold all carbonates are soluble in water. Ba++ plus 2HCO3 minus BaHCO3 2 soluble H2O plus CO2 evolved plus BaCO3 and boil.